Hello students, welcome back. Now we have one more section to go, tangency problems, but I'm not exactly sure whether this section is the best place right here, or maybe I should cover it a couple of weeks later when we deal with linear approximations. But more can always replace less, so let me prepare, and if I decide to skip, I'll skip. How do you find a tangent line? Here is a step-by-step process. Basically, you're looking for the slope point equation of the line. Y equals to mx minus x0 plus y0. A line that is running through x0 comma y0 with a slope m. Now, how do you find out y0? And how do you find out m? That's the problem because x0 is given from the problem. You see, x equals to x0, that's given. Y0 you can find out by just plugging in x equals to x0, whatever. Now, how do you find out the slope? You have to take the derivative and then plug in x value. So we have y0 value in step 1, and m value in step 3. Put those two together, and at step 4 we get the final answer. Am I making sense? Well, I hope to make a little bit more sense through our example problem, and here we go. Step 1, plug in x equal to 3, and that's going to give me y0 value. And this is, well, you figured it out. And now you have to find out this derivative function. Once you have the derivative function, then you can plug in f prime of 3, and that's your slope. And once you have the slope, you get y equals m x minus 3 plus y0. y0 you found out from step 1, and m you found out from step 3. Here we go. Plug in x equal to 3. Excuse me. Sorry about the cough. I'm recovering from COVID right now. Plug in x equal to 3 and do your computation, and we get y0 value. It's 3/2. Alright, now let's go to step 2. In order to take the derivative, I need some algebraic manipulation. Change everything into the power form like this. 1/2 x squared minus square root of 3 times x to the 1/2 power, because square root is 1/2 power function. And then we take the derivative using the power rule. Make sense? 1/2 is multiplied over there. We get square root of 3 over 2, and then negative 1/2 power. Okay, and then we get this. Now, finding out the slope is just plugging in x equal to 3 and plug it in, and with the help of calculator, you can get this value. It's not too bad, 5 over 2. We have square root of 3 canceling each other, so it's not too bad. So we have the slope, 5/2, and then we have point, 3/2. Put everything into the slope point equation, and that's the end of the problem. Now, you want to get a little bit further for slope-intercept equation, but to me, that's enough. Slope point equation is enough for me. But if you read some textbook, including our own textbook as a matter of fact, you have to get to the slope-intercept equation. I think that's not really a part of calculus. I think it sucks, but sometimes you have to do that, especially if you're dealing with machine graders. If you have to do this for a website or something, then you have no choice. You have to do it because the problem asks you to do it that way. Me, I'm a human, so if you stop here, then you're going to get full credit. No need to simplify further to get slope-intercept equation. Never mind about that. Yeah. Find an equation of the tangent line. Any equation will do. Slope point equation, slope-intercept equation, anything is okay. Here's a visualization, by the way. It turns out, yes, indeed, we have the tangent line. Next problem. Well, this is a bit more challenging. I'm going to leave that to you. Remember, plug in x equals to 1 to do your computation. That's going to give you y0 value, not the slope. Slope requires the derivative. Calculate the derivative and then plug in. So you have to do two plugins. Plug in directly, that'll give you y0 value. Take the derivative and then plug in, and that is m value. We need both. As for this problem, well, answer key is posted here, so I'll leave you there. Otherwise, the detail is left to the students.